Hello, welcome to a new day in our logarithm chapter. Today we're going to learn about graphing, a little bit about logarithms, and we're also going to learn a little bit more with our logarithm rules. First, we're going to review the rules that we learned yesterday. We learned that log base a of xy, that's x times y, we can separate it as log base a of x plus log base a of y. Also, log base a of x over y is equal to log base a of x minus log base a of y. So if it's divided, we subtract. Now this one, which is a pretty big rule, log base a of x to the b power, we can pull that b out in front, so it's b times log base a of x. So for instance, if we want to simplify this, notice that they all have the same base, so we can use our rules. This 2 can come up as an exponent, so this would be log base 8 of 5 squared plus log base 8 of 4 minus this again can go up into the exponent, log base 8 of 2 to the third power. Now here we can say, we can just simplify it. Forgot my base 8 down there. 2 to the third, that is 8. Alright, now when it has an addition sign, we multiply those numbers. So log base 8 of 100 minus log base 8 of 8. And now, since it's subtraction, I divide. So it's log base 8 of 100 over 8. So 100 divided by 4 is 25. So 100 divided by 8 should be half of that, which is 12.5. So our missing piece here was 12.5. Alright, so now let's look at these two graphs. E to the x and natural log of x. We could take a second and graph them. So turn on your graphing calculator. If you find the natural log of x button, if you hit second natural log, it should give you the e to the x button. But e to the x is going to be a function that looks like this, and natural log is going to be a function that looks like this. Now we can do a simple chart here where we can have x's and y's. If x is 0, e to the 0, or anything to the 0 for that matter, will be 1. If I have x is equal to 1, x is equal to 1 means we have e to the first. And e to the first is just e, which is 2.718281828, blah, 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 goes on forever. So let's just say about 2.7. So if I go out to 0, I go up 1. If I go out 1, that goes out to 2.718. And then we go to 2, and then it's this number squared, and so on. And as we go less than 1, now it would be 1 over e, which is 1 over 2.718. So it gets closer and closer to 0 as it moves to the left. Now this is the opposite. So it's just like changing your x's and your y's. So if I want to find the natural log of 1, that's saying e to which power equals 1? That answer is 0. If I wanted to put e on here, then that means I'm having e on this side. So e to which power is e? That answer is 1. If I have 1 over e, like I have over here, e to which power is 1 over e? That would be negative 1. So notice how these produce inverse graphs. And you can tell they're inverses because this would reflect over the y equals x line. Alright, also, with 10 to the x and log base 10, we could graph these on our calculator. Oop. Maybe I'll start up here. trace x. Starts close to the axis, curves pretty quick. Now if I made my x and y on this graph, if I did -1, 0, and 1, at -1, it would be 10 to the -1, which is 1/10. 0, again, is 1. 10 to the first is 10. So this value is at 1. And when it hits 1, it'll happen at 10. Now when it, by the time I get to -1, it's already at 1/10. So this one hugs the axis a little bit more than our previous one. It goes up faster when it's positive. It gets closer and closer to 0 as it gets negative. Now log of x will be just the inverse, because if I put in 1, that's like saying 10 to the what power is equal to 1. That answer has to be 0. Now if I put in 1/10, this is like saying 10 to which power is 1/10, and that answer is -1. Or if I put in 10, so when x is 10, 10 to which power is 10, and that would just be 1. So way out here, it'll be 10 and 1. Alright, so now we're going to do some linear transformations on this. What transformations would occur to the graph y equals natural log of x when we have y is equal to negative natural log of x plus 1? Well, we could graph this on our calculator, but I think we can do this without graphing it on our calculator. First thing we have to think of is our natural log graph. Remember, our natural log is right here. It's going to move up 1, and so we can pretend that this is our new x-axis. And now it's going to flip over the this axis that we have here. Now I'm going to, let's do this in a different color. In green, I'm going to draw it just with the +1. If I just had the +1, then it would cross here at 1, and it would come up, and then it would go out like that. Now if I reflected over this line, y equals 1, I'll produce my new line where it comes down, oops, crosses through my point, and then curves out. So this blue line is the actual line, y equals negative natural log of x plus 1. Now, once I get here, I can erase this other business, so you know exactly what I'm talking about. Alright, so let's do this. 3 log of x plus 2. Now take a second and see if you can sketch this on your own. Alright, hopefully you've paused the video and sketched it. This x plus 2 is going to move it to the left 2. And now pretend like this is our new y-axis. So now let's just, I'll draw this again in green. So if I was just going to do my log, it would be really close to the line, come up, and then hug pretty close in this direction. Now, what that 3 does is it multiplies all the y values of this by 3. So this would be 9, 1. So now instead of 9, 1, it would be 9, 3. At this point, 0 would still be at 0, because 0 times 3 is 0. And now, now as we move this way, it will just widen out here. So our graph would look something like this. So it just multiplies each of these values by 3. So all those y values are stretched out. Now I can erase my green graph, and so you can see how exactly this one works. Now let's look at the domain of this. I forgot to do this in the previous problem. I'll go back to it. Now the domain, which x values does this function take on? Well, it never reaches -2. So we'll put a parenthesis there, and it doesn't reach -2, and it goes to the right forever. So from -2 to infinity. All right, the range values, well, it goes all the way down and all the way up, so we can say -infinity to infinity. All right, so now let's look at this. The domain values goes from 0, not including 0, all the way to infinity for our domain. And again, our range goes from -infinity to infinity. It goes all the way down and all the way up. All right, 2 plus natural log of -x. Now that negative's in a different position than it was previously. So instead of flipping it vertically, we're going to flip it horizontally. That 2 means we move it up 2. So pretend like this is our new x-axis. So if I was going to do this in green again, our natural log would be coming up and pass through here and then go off to the right. However, we're flipping this over the x-axis. So we're going to come down and up and over. So that blue is what we're looking for. Or did I say x-axis? Y-axis is what we're reflecting over. And that blue graph is what we got. Now our domain goes from -infinity all the way up to 0, and not including 0, so we use parentheses. And the range again goes from -infinity to infinity. All right, now let's look at the domains of these. Now, the domain of natural log, when there isn't anything in the parentheses, is from 0 to infinity. If there was a +2, I went from -2 to infinity. And if it was a negative, I went from -infinity to 0. So that just flipped it around. So what I can do with this one would just be, it's like solving for 0. X plus 5 is greater than 0, so if I subtract 5 on both sides, x will be greater than -5. So my domain on this would be from -5 to infinity. If I try this one, x minus 3 is greater than 0, add 3 to both sides, goes from 3 to infinity. 2x plus 12 is greater than 0. Subtract 12 on both sides. Divide by 2. X is greater than -6. This goes from -6 to infinity. And now the toughest one so far, the one that changes up a little bit, x squared minus 4 has to be greater than 0. So I add 4 to both sides. And now I square root both sides. Now square rooting really throws things for a loop. If this is positive, so if positive, I don't think you guys have probably ever seen this before. So if these are two positive x's, then you square root both sides, and the answer would be x is greater than 2. Now, if it's possible that both these are negatives, -2 times -2, and now that would be like dividing by a negative. So if I take the square root of sides, it would be x is less than -2. So our domain has two things. X goes from -infinity all the way up to -2, and then we'll have that union with 2 to infinity. Now, if you take a second, I would graph this function. Log of x squared minus 4, and just get an idea of what this looks like. And on our standard, if we do zoom standard, it kind of looks like this, where there are no values between -2 and 2, but everything less than -2 there are values, and everything to the right of -2 there are values. Alright, now we're going to do some solving for x. So x is right here, so first thing we can do is divide by 9 on both sides. So I have log base 6 of x plus 5. 18 divided by 9 is 2. Now in this situation, what I think is the best is to put this in exponential form. So my base is 6, my exponent is 2, and that's going to equal x plus 6. Now hopefully from here, it just looks easy for you, because now we just have to subtract 6 on both sides, and 30 is equal to x. Now, is this answer in the domain of the function? If I put 30 up here, can I do 30 plus 5, take the natural log, or take the log of that, multiply it by 9, and get 18? Yeah, 30 plus 5 is 35. If I take log base 6 of 35 times it by 9, that should be in the domain, so yes. Alright, for this new problem, we do the same thing as we previously did. We subtract 3 from both sides. Natural log of x minus 4 is equal to 3. So now this has a base of e, so this is saying e to the third power is equal to x minus 4. Now if I add 4 to both sides, I have e to the third plus 4 is equal to x. Now we could do this on the calculator, and if we did this on the calculator, we'd actually get a real value. E to the third plus 4 is 24.08. 5533, so on and so on. That would be the value for x, but we accept e to the third plus 4 as an exact answer. Now, is this in the domain of the function? Well, let's see if we can get a value. If I plug in e to the third plus 4, e to the third plus 4 minus 4 is e to the third. Natural log of e to the third is 3. 3 plus 3 is 6. So yeah, it is in the domain of the function. Now try this one. We have 4 to the second power is equal to 6x minus 2. So we have 16 is equal to 6x minus 2. Add 2 to both sides. Divide by 3. Or not divide by 3, divide by 6. And your answer will be 3. Now is this in the domain of the function? 6 times 3 is 18. 18 minus 2 is 16. 4 to the second power is 16. So everything works out perfect. Now this is where things start to get a little tricky. We have two x's in two separate equations. Since log is in both of these equations, we can combine them, saying it's log of x plus 1 over x minus 1 equals 2. So the base here is 10, so 10 to the second power is x plus 1, x minus 1. So getting here isn't the tough part. The algebra, I think, is the most difficult part. Here we'd want to multiply both sides by x minus 1. X minus 1. So you would have 100 x minus 1 is equal to x plus 1. 100 I got from 10 squared. Now I distribute that over the parentheses, so that's 100x minus 100 is equal to x plus 1. Now I would subtract x from both sides, leaving us with 99x minus 100 is equal to 1. Add 100 to both sides, so 99x is equal to 101. Divide by 99, 101 I should say. And so 101 99ths is going to be our value for x. Now, is that in both of the domains? Well, both these domains will accept anything. This is anything greater than -1, anything greater than 1, and this is a little bit greater than 1, so it'll fit into the domain on both of them. Alright, let's try this one. natural log of x plus 1 plus natural log of x minus 1. So we can combine these. X plus 1 times x minus 1. And we're multiplying because there's an addition sign between them. X plus 1x minus 1 is going to be x squared plus 1x minus 1x minus 1, which would just be the same thing as x squared minus 1. So I have the natural log of x squared minus 1 equals 0. So if I take my e down here to the 0 power is equal to x squared minus 1. Now e to the 0 is 1. Add 1 to both sides. So 1 plus 1 is 2. And now when I square root both sides, I'll have plus or minus square root of 2 is equal to x. Now let's look and see if both of these answers fit in the domain. This one will accept all x's that are greater than negative 1. This one will accept all x's greater than 1. Are both these answers greater than 1? Hopefully you're saying no. Square root of 2 is 1.4, but negative square root of 2 is, of course, less than 1 because it's negative. So the only real answer for this one is the square root of 2. All right, let's try one, couple more of these actually. If I multiply those together, that's log base 2, x minus 1 times x minus 3 equals 3. So 2 to the second power, or 2 to the third power, is equal to, if I multiply this out, this will be x squared minus 1x minus 3x, and then plus 3. So 8 is equal to x squared minus 4x plus 3. Now, in this situation, what we do is we want to solve this side to be 0. So 0 is equal to x squared minus 4x minus 5. And now we want to factor this. So this would be x minus 5, x plus 1. What multiplies to negative 5 adds up to negative 4. So my x values will be 5 and negative 1. Now let's check and see if they work. Here, this will accept everything greater than 1. This one will accept everything greater than 3. So negative 1 won't work here. X equals 5 is the only correct answer. Let's do natural log 1. This would be natural log of 3x minus 1 times x plus 1 equals 0. So e to the 0 power is equal to, this would be 3x squared. The insides would be minus 1x. The outsides would be plus 3x. And the last would be minus 1. E to the 0 is 1. 3x squared plus 2x minus 1. So 1 is equal to, now we have to factor this. We have a 3x and an x. And this one has to be 1 and 1. The 3x has to be positive because we need 3 positives and 1 minus. Ooh, but we're forgetting something. We have that 1 on this side, so I factored it with that 1 being in there. We got to get rid of that 1. So subtract 1 from both sides. And so I'll have 0 is equal to 3x squared plus 2x minus 2. So let's see if this will even factor. I don't think it will. We have 3x and x. How can I get a 2x? This has to be 2 and 1. That would be 2 and 3. That won't make it. And if I flipped it around from 2 and 1, this would be 6 minus 1, and that won't make it. So if I want to find my values here, I have to use the quadratic formula. So it's plus or minus b, or negative b, plus or minus the square root of b squared minus 4ac all over 2a. So negative 2 plus or minus the square root of 4 minus 4 times 3 times negative 2 all over 2 times 3. So this would be negative 2 plus or minus 4 minus or plus 24 all over 3. Negative 2 plus or minus root 28 over 3. Now the square root of 20, we can only accept values. This one, whereas 3x minus 1 is greater than 0. So that would be x is greater than 1/3. And over here, x has to be greater than negative 1. So which of these has an x greater than 1/3? So the square root of 28, well, if I did it on my calculator, I got 5.2. So negative 2 plus 5.2 divided by 3 would give you a positive answer. But if I did the negative, it would give us a negative answer. So the only correct answer here is negative 2 plus root 28 over 3. All right. Hopefully that's enough to get you through the homework. Good luck.